Hello all, welcome to this session of OpenMentor.net. In this session we are going to talk about arithmetic operations. Let us define a variable int x. So what I'm going to do is I'm going to initialize x equal to 5. So basic assignment operator. Now I want to say let us have two variables x comma y. Now I'm going to say y equal to x plus 5. So this is addition. Now if we want to say x equal to x plus 5. So pretty much you use x plus 5. You can also use minus x minus 5 or x into 5 or x divided by 5. This is also possible. All these addition, subtraction, multiplication, division are possible. Now if I want to say x equal to x plus 5, let me print this out. Printf %d/n x. So I'm going to print this. So initially x equal to 5. So when I say x equal to x plus 5, it will be 10. So let us execute this. Now it prints 10 over here, which is good. I can write the same thing in a different manner. Rather than saying x equal to x plus 5, I can always say x plus equal to 5. The effect is exactly the same. This is equivalent to x equal to x plus 5. So let us execute and then see whether we get the same result once again. You got it. It's the same thing. So it shows 10. This means x equal to x plus 5 you can write in this fashion, whereas y equal to x plus 5 you cannot write like this because this is a different variable, this is a different variable. If you want to just do the same operation on the same variable, you can use plus equal to or minus equal to or star equal to or divided by equal to. This is possible. Now I want to do one more thing. If I want to have the modulus operation, y equals x modulus 3. So modulus of 3 meaning it will divide the variable x by 3. What is going to be the remainder? That will be the result. So if y equals initially x was 5, y will become 5 plus 5 10. 10 divided by 3. When it comes over here, the modulus I expect as 1. Okay, let me execute this line. Instead of printing x, I'll print y. Okay, so initially x is 5, y is 5 plus 5 10, 10 divided by 3, and modulus is 1. Let us print it out, see what we get. Now you get modulus as 1. Modulus is nothing but the remainder. Okay, so modulus operation is percentage sign. So these are all the fundamental add, subtract, multiply, divide, and then get the modulus numeric operations. There is something called increment and decrement operations. Suppose I want to say x equal to x plus 1. I can always say, suppose x equal to 10. When it comes to this line, I want to increment x. I have two options, x equal to x plus 1, or I can simply say x plus plus. So the moment I do this, x is incremented by 1. So this is same as x is equal to x plus 1. So only thing is it reduces my space in writing. Okay, let us execute this. So it is 11. So 10 plus plus, that's 11. The same thing you can do as minus minus also. If you do this, 10 minus 1 equal to 9. The same thing you can also do in terms of plus plus x. Okay, so let me show you the difference, the x plus plus and plus plus x. Let me show you the difference. Now I show you this one, x equal to 10. Just watch carefully. Now I am printing this. So printing is the primary operation. Within that I am giving x plus plus. So what do you expect? 10 plus 1, 11. Let us execute and then see what happens over here. It simply says 10. It doesn't say 11 because this operation is contained within another operation. So printf takes precedence. First it takes the value of x, executes the printf statement. After the printf statement is done, it is incrementing x by 1. Whereas if I want this plus plus to take effect before, you need to put that before x. So if you say plus plus x, now you do the same thing. It says 11. So the moment you have the prefix plus plus, this operation happens first, then this operation happens next. Instead, if you have it as a suffix, the container operation takes first, then the post increment or post decrement happens next. So these are all the fundamental arithmetic operations. I hope this is clear. On the numeric variables, there is one other thing that you can also do, which is nothing but bitwise shifting. For example, if I have x equal to 8, the binary equivalent of 8, or say octal equivalent, is 0 1 1 0 0 or 1 0 0 0. This is the 4-digit binary equivalent of 8. So if I want to do, there are something called bitwise operators. I can shift the bits left to right. Ideally, if you look at the 1 byte, it will be like this: 0 0 0 0 1 0 0 0. Int x will have 2 bytes allocated to it, so it will be like this. Internally it will be like this. So the first byte will look like this, the second byte will look like this. So 1000 is equivalent to 8. Now if I say x equal to x left shift by 1, okay, when I say left shift by 1, this 1 will move over here. So instead of 1 followed by 3 zeros, it will become 1 followed by 4 zeros. What is the equivalent of it? Let us print that. Okay, let us print that. So when you use this bitwise operators, it takes the binary and moves the digits one by all the bytes, or all the bits will be shifted. It's not just this one. Suppose I have a 1 over here. If I have 17, something like that, I will have another ones over here. All things will move 1 bit left. Okay, now let me execute this. So it shows 16. Okay, it shows 16. That's a simple trick. Whenever you are doing a left shift by 1 bit, it is getting multiplied by 2. Same way, if I do it right shift by 1, watch what happens. It becomes 4. It is getting divided by 2 because all the things are stored internally in binary system. So the moment you move this one, it comes over here, it is getting multiplied by 2. The moment you do a right shift, this one goes here, and all these things will be filled up to the left by zeros. Now it becomes 1 0 0, which is equivalent of 4. So this is bitwise operators on numeric variables. I'll stop over here. In the next class we will talk about string operations. Thank you.